everyone, welcome to the computer edit drawing class. In this video I'm going to show you how I'm going to introduce to you the 3D AutoCAD 3D or 3D modeling using AutoCAD. What we discussed before, we discussed how we can and we practice how we can draw or generate two-dimensional sketches using AutoCAD. Now we're going to discuss the 3D modeling using AutoCAD, and we're going to practice and we're going to know how we can build 3D objects whatever they are simple objects, 3D solids or objects, or complicated ones. So we're gonna go over the different commands and different features of building 3D solids using AutoCAD. And starting with this video, I'm gonna focus more on the standard shapes, and I'm gonna show you how we can build these simple and standard 3D objects using AutoCAD. But before we move on to the 3D modeling, we have to discuss the workspace or the work area of the AutoCAD and the different commands and how we can switch between 2D sketching and 3D sketching or 3D modeling to be more accurate. So as we discussed before, if we just started the AutoCAD, this is going to be the main window, the first window that you're going to see, and this is going to be the start. That from here you're going to start by clicking on one of these templates of the AutoCAD, and as long as we're already working according to the international system in terms of units and in terms of engineering drawing, so we are following the ISO system for engineering drawing. So we have one of the two options, either to choose a CAD ISO.DWT, which stands DWT stands for T stands for the template, and a CAD ISO, it means that we're gonna choose this template in case that we are interested in working in 2 dimensions. So we're gonna have the conventional window or workspace of the AutoCAD 2D. And if we're already interested in 3-dimensional modeling and we would like to have this space in the 3-dimensional way, and as you can see here, we're already working in 2 dimensions, so we do have the X and Y coordinates. It means that we can draw over the XY plane only. And if we're already interested in 3-dimensional thing, we can, instead of choosing a CAD ISO DWT, we can choose the CAD ISO 3D. A CAD ISO 3D is gonna give us the same window, but in the 3-dimensional representation. It works like you already working like animation or modeling software, like the 3D Studio Max, if you do have any previous experience with such a software. So this is it's gonna be the AutoCAD ISO 3D, and this is the AutoCAD ISO 2D. So we said that if we are interested in generating 2-dimensional sketches, there is advice to choose the AutoCAD ISO .DWT template, which is this template, and we practice how we can use all of these different commands and these panels of the AutoCAD 2-dimensional sketching. And as you can see, when we switch or choose even another template, which is AutoCAD ISO 3D, we still have having the same panel, although the workspace has been changed from 2-dimension, which is this one like XY plane, to 3-dimensional plane like or space like X, Y, and Z. So we're already working at 3-dimension. So although we do have this switch from 2-dimension to 3-dimension, the panels is still the same. And there are no commands that would be used for building 3-dimensional solids. We need some special commands for building 3-dimensional solids. And to do so, we have to switch the workspace, and switching the workspace, including as well the switching to the other set of panels that would be used for 3D modeling. And this is what we have to do. So to start building a 3D solid, you have to switch whatever you started. You can even start with 2-dimensional sketching. You can start with the AutoCAD ISO, or you can start with the AutoCAD ISO 3D. It's up to you. But the key idea that you have to change these set of panels. Like you have to come up with other set of panels that would be used for building 2-dimensional models. And this is what we need to do first. So, but these panels, these are the ones that use for 2-dimensional sketches, or as named by AutoCAD for drafting and annotation. Drafting, it is more related to the 2-dimensional sketching, and these are the commands and the panel that would be used for such a case, for building 2-dimensional model. So how we can change the panel from 2D to 3D modeling, or 2D sketching, or drafting and annotation to 3D models? This can be done if you clicked on the options here. You're gonna find this icon, which is like the setting icon. This is, if we come closer, it gives us the workspace switching. Like we can switch between two-dimensional sketching or three-dimensional modeling, and this is what we would like to do. If we switch, it means that you're gonna end up with different panels. So observe the panels, and what I'm gonna do, if you just press on this arrow next to this icon, you're gonna see this list. So we do have here the check. We already checked. The check is already in front. The drafting and annotation. This is for two dimension. This is the workspace for the two-dimensional modeling. If you would like to convert to the three-dimensional modeling, there are two options here, which are three-dimensional basics and three-dimensional modeling. So in the earlier versions of AutoCAD, like 2001, 2002, 2003, 2000, up to 2007, or before 2007 actually, there was no difference in the workspace between the two-dimensional sketching or the drafting and the 3D modeling. It means that this option, this list here, this icon wasn't included in the earlier versions of AutoCAD. But starting 2007, AutoCAD start to switch or change or distinct between two-dimensional sketching and three-dimensional modeling using workspace. So this workspace option, it had been included since 2007 and the other versions. Even initially, it was just two options. You had initially in the 2007, 2010, and some versions, there was only two options, like either drafting and annotation and 3D modeling, and that's it. There wasn't 3D basics. But in the recent versions, like this version is 2018, and the current versions, we do have three options here, like drafting and annotation for two-dimensional sketching. We do have 3D basics, and we do have the 3D modeling. There is no significant difference between 3D basics or 3D modeling. So you can choose either one. You are in a good shape, and you can build with either two options or two workspaces. You can build 3D solids with the same way almost. The only difference is just a few things. Some special commands or more commands will be added in the 3D modeling. These commands mainly is going to be used for like animating the object, giving it motion if you would like to give animation and motion to the object. Again, the same company, the idea of AutoCAD, because the company that made AutoCAD, it is Autodesk. And Autodesk is the same company who is already providing the 3D Studio Max. 3D Studio Max, it is animation software that building for animated characters, and you can build a character. This is known as modeling. To build a character, this is modeling. To give animation to this character, it is the animation. So it is like you're already building a movie in 3D Studio Max. And the same company, it takes the same idea. It works with the same concept, but for engineering application, and they provide to us the AutoCAD. So AutoCAD, it works with the same concept, very similar to the 3D Studio Max. So that's why we have here 3D modeling. It means that we can use AutoCAD for building a solid. In starting 2007, they started adding a new feature to the AutoCAD by giving animation to some of the solid objects, very similar. It is not typically very similar to the 3D Studio Max, but they picked some features of the AutoCAD 3D Studio Max, and they put it in the, in the 3D Studio Max, they picked some features and commands in the 3D Studio Max, because 3D Studio Max, it is more general, more common, and they included some of these commands in the AutoCAD software that would be used for engineering application. So going back to the workspace, if we are interested in generating two-dimensional sketches, we have to make sure that we're already checking or choosing the drafting and annotation. So you're gonna see all of these panels that we practiced before for drawing, for modify, for annotation, for putting layers and dimensions, everything. We practiced these things before, right? And this is what we practice to do for two-dimensional sketches. But if you are interested in building 3D solid, so you have two options, either to choose 3D basics or modeling. Both you're gonna do the same thing. There is no significant difference between 3D basics or modeling. Either one is acceptable, and you can build the 3D solid with the same two workspace. So for example, I'm gonna show you both of them. If we choose 3D basics, as you can see, the workspace is still the same, still two-dimension. The work area is still two-dimension, but the panels has been changed. The icons has been changed. Now, instead, previously into the two-dimensional drafting, in the drafting and annotation, we had draw, modify, and annotation, layers, and so on, right? But now we do have create. Create, it means that we're gonna build a 3D solid object, then we can edit to this 3D solid. It is works with the same concept like two-dimensional sketches. As we said before in two-dimensional sketching, that we have to draw an object, we have to build an object first in the two-dimensional sketch, then we can modify over the two-dimensional sketch. The same concept, we have to build a 3D solid first, then we can modify or edit over this 3D solid. So you could say that these two panels, these are the two main panels that we're gonna use, and this set of commands are the essential set of commands that we're gonna use for building and editing a 3D solid, and this is what we're gonna do using AutoCAD. Make sense? So how about if we switch it to the three-dimensional modeling? There is nothing significant. The three-dimensional modeling, we're gonna have almost the same panel. We do have the modeling, but instead, which is like create. This is the create panel and modeling, and this is the solid editing. So this is the edit panel, and this is the modeling or the create panel in the 3D basics. But there are some more advanced features that already included in the 3D modeling, like smoothing the object. This set of commands here, they are typically the same command that found in 3D Studio Max. I had an experience with 3D Studio Max and I used this software. The same commands are still there. So why AutoCAD including these commands? As I said, they picked some features of the 3D Studio Max and they are including them in the new versions of AutoCAD. But in my point of view, they are not essential. They are not needed when it comes to engineering drawing, like mechanical engineering and even some engineering application like civil engineering drawing. But for architecture, for example, they might need building 3D solid with a beauty, with a good shape, with a beautiful shape. So they might need these types of commands. And it is much more recommended for architectures to use 3D Studio Max over even AutoCAD, because 3D Studio Max is much more common and general than AutoCAD. But in terms of the engineering application that we're gonna consider as mechanical engineers, either ways, we're just gonna depend more on modeling and editing the solid object. So either options, either you choose the 3D basics or the 3D studio or the 3D modeling, both are the same to us and we can build the same thing using the two workspace. Make sense? So for myself, I recommend much more to use the 3D basics, because this is what we need. We're gonna need more than the basic thing in terms of engineering or mechanical engineering drawing for building 3D object. Make sense? So if we choose the 3D basics, this is gonna be the window. And the interesting of this workspace that even we do have some features related to the two-dimensional sketching, like we do have here creating 3D solid, we do have editing over the 3D solid, we do have some commands, the essential commands for drawing two-dimensional sketches. We still have the essential commands for modifying a two-dimensional sketch. So this is 3D model, editing over a 3D solid, two-dimensional sketches, this panel, and this panel is for modifying two-dimensional sketches. So you could say that we have everything, 2-dimension and 3-dimension in one workspace. So that's why I much more recommend the 3D basics to be used over the 3D modeling. But even as I mentioned, you can use the 3D modeling, but in 3D modeling, you're gonna see the 2-dimension. You're gonna find here the draw, also the modify, but it's gonna be much more, like more commands and more. It includes more features, definitely, but these features, as I said, it gives more beauty and it is not necessary to be used in terms of mechanical application. So the both two workspace are enough. You can pick your own and practice using it. You are in a good shape. Make sense? So this is simply how we can switch between 2-dimensional sketches and 3-dimensional sketches, or even if you just choose 3D basic, you'd have almost everything in the 2-dimension and the 3-dimension. So the question is, why, since we're gonna work in 3-dimensional modeling, why do we have commands here for 2-dimensional sketches? Like line, as we said that any 2-dimensional sketch, it will be consistent of set of lines, circles, arcs, curves. So we'd have all of these draw commands, the conventional thing, drawing circle, and drawing line. These are the essential, and arc. These are the essential commands for creating any two-dimensional sketch. And these are the essential commands for modifying over the two-dimensional sketch, the same commands. So why we do have these two-dimensional things, although we're gonna work in three-dimensional modeling? The concept of any software, I'm talking in general, the concept of 3D modeling in terms of science, in terms of 3D modeling science, which it is not necessary here. I'm not talking about AutoCAD. I'm not talking about a special software like SolidWorks or whatever. Any solid software for 3D modeling that is used for 3D modeling, it works with the same concept. That we cannot build, in terms of computational 3D modeling, we cannot build a 3D model at once. We have to convert a two-dimensional sketch first. We have to create a two-dimensional sketch. Then we're gonna convert this two-dimensional sketch into a 3D solid. So how we can build 3D solids or models using any software? It is not necessary to be AutoCAD. Using AutoCAD, SolidWorks 3, even 3D Max, it works with the same concept. That we have to start with a two-dimensional sketch, then we're gonna use one of these commands of the creation to convert. These commands, they are not building 3D solid. These commands are converting two-dimensional sketch into a 3D solid. So it means that you should have first a two-dimensional sketch, and that's why we started this course practicing more on two-dimensional sketches, and we spend enough time to practice you how you can create two-dimensional sketch. Then using some simple commands, you can convert this two-dimensional sketch into a 3D solid. This is how we build a 3D model using AutoCAD or any other software. Make sense? So what does it mean this? That's why this explains why we do have commands for two-dimensional sketches in the same workspace of the three-dimensional modeling. Because we have to draw two-dimensional sketch first, then we're gonna use one of these commands to create an object, then we can use one of these commands in the edit panel to edit this 3D solid. This is how it works. Make sense? So that's why it is important, again, to know how we can switch between these different workspaces, to understand these different panels, and why we do have two-dimension plus three-dimension in the same workspace. As you can see, the work area here, it is two-dimensional. In this case here, there is three-dimension, but we still have the same panel. So the switching here, this is gonna change only the top. It's gonna change the panel. But it won't gonna change the work area. The work area, it would be two-dimension or it would be three-dimension. And by the way, we can so easy convert this two-dimension into three-dimension, and we can reset it back again to the three-dimension. So what does it mean? It means that even if you started, if I start in the start here and I choose a CAD ISO, you can work three-dimension, no problem. Okay, so it is not necessary that you choose a CAD ISO 3D. You can choose a CAD ISO 2D and you can build 2D model, then you're gonna convert it 3D or 2D sketch, then you're gonna convert it into 3D model, then you can visualize or see this 3D model as in three-dimensional workspace, as I'm gonna show you. So what does it mean? It means that I can switch between two-dimension, as the current case, into three-dimension, and I can reset back. Make sense? So now let us move to the view cube and the visual style. See, as I mentioned, we can easily switch between two-dimensional view into three-dimensional view, and we can reset back. So this is commonly known as switching or changing or adjusting the view cube or the view panel, whatever it is, two-dimensional or three-dimensional. This is the view, like three-dimensional view or two-dimensional view. Currently, we do have a two-dimensional view. So we can convert into three-dimensional view. Also, we do have something that we're gonna call visual style, how you're gonna see the object. So I've created a 3D solid. This thing, it should be a 3D solid. But as you can see, to me, it is just rectangular shape or square, right? It is just two-dimensional sketch. Why? Because you don't see the third direction. You don't see the Z direction. We're already working in two-dimension. So the question is how we can change the view from two-dimensional view to three-dimensional view. This can be easily done using this view cube. This cube, you can use this one to like play with the 3D solid, give orientation and look at it from the different angles. or different views as we discussed in the projections part, right? So this view cube, if you clicked on anything, you're gonna end up with different views. The current view, it is the top view. This is the top of the object. This is the top view. As we discussed before in the projection, any 3D solid, it has infinite. In general, it has infinite number of projections, infinite number of views. But the standard things are 6 views, like it is a cube. So that's why we do have a cubic shape here that represent the different 6 faces of the cube. We do have the front, we do have one right side, we do have left side, we do have the top, we do have the bottom, we do have the back. So these are the 6 faces, the 6 views of any solid object. If we would like the current view, the current angle from which we are seeing this object is the top view, is the top angle. If we decided to switch to another angle, if you just move the mouse without clicking anything, you're gonna see lots of things shows up. If you just move off, so these things are hidden. So once, for example, you're gonna see here some of these arrows. How about if I pressed on this arrow, you are telling AutoCAD, please give me a view of this object from this angle. If you pressed on this arrow, you are asking AutoCAD to give you a view of the object from that angle, and so on. Like for example, I can look at it from this side. This side is the right side, so this is the right side of the object. I can look at it from this side. This is the front view of the object as written here. I can look at it from the top. I can look at it from the front. I can look at it from the bottom. So if you press this one, you're already going to the bottom of the object. I can look at it from the left side view of the object. So these are the 6 views that the different angles that we can see by which this object. But as you can see, all of these angles are 2-dimensional sketches. All of these angles are different 2-dimensional sketches here, 2-dimensional. Like YZ, this is the YZ plane. If I pressed on this one, I'm moving to another plane like XZ plane. If I pressed on this one, I'm moving back to the XY plane. Make sense? Another thing that you can observe over the UCIS, which is UCS, which is the user coordinate system. Over the coordinate system here, as you can see, just observe this square little box here in the XY plane. And if I switch to another plane, like for example XZ plane, in the XZ plane there is no box, there is no square at the 0 point of the XY plane, of the XZ plane. Like this plane, for example, in the YZ there is no box here, but in the top view, in the XY plane, we do have a box. Why? This indicates something that we can explain later. This indicates, but I'm gonna tell you about it very quick, then we can explain this one with more detail later. There is something in AutoCAD you should understand how AutoCAD is working for creating 3-dimensional solid. It is a little bit complicated, by the way, than other software like SolidWorks. It is much more practical. SolidWorks or Solid Edge, these software are more practical in 3D modeling than AutoCAD. But AutoCAD, if you understood the concept of building 3D solids using AutoCAD, you can easily handle it. AutoCAD, this square box indicate that if you decided to draw a 2-dimensional sketch, this 2-dimensional sketch will be shown over the XY plane. But for some reason, if you try to draw 2-dimensional sketch over this plane, it will not be seen over this plane, it will be seen over the XY plane. Why? There is no square box here. So this square box indicates whatever the plane or the sketch that you are going, I'm talking about the 2-dimensional sketch, is going to be shown over this plane or not. According to this coordinate system YZ, it means that if you try to draw any 2-dimensional sketch, for example, if I decided to draw a line, this line is not shown here in this plane, it is shown in another plane. This is the key item. Make sense? So, and we're gonna explain this point with more detail as we move on through this part. So, this is simply how we can use the view cube or box to switch between the front view, the side view, the top view of this 3D solid. And we can simply come up with the projection. These are the things that we used to struggle with in the 2-dimensional sketches on the projections by hand. So if we succeeded to build a 3D solid of the object, real object, we can simply project it into front side, and we can simply come up with these projections very easy. But the question is how we can build the 3D solid. This is what we are already discussing in the rest of this class. Make sense? How about if I am interested to see the object as isometric view? We explained this isometric view in the projections. We said that to see the object as a 3D solid at once, so you have to represent it over the X, Y, and Z, the three coordinates. Here, there is missing Y axis. If I looked at it from this side, there is missing one axis, which is X axis. From the top, there is a missing axis, which is the Z axis. How about if I'm interested to see the object as a 3D solid, real 3D solid in front of us in the three directions, X, Y, and Z? To do so, you can click, for example, one of the things you can click at one of the corners. As you can see, as you move, you can align or give focus. If I clicked on this corner, I'm asking AutoCAD to align, to give rotation, or to represent the 3D solid in an angle that makes the focus over this corner. And if you remember in our definition of the isometric, and it's the difference between the isometric and the oblique 3D solid, as we discussed in the projection, the isometric gives focus on the corners. So if I clicked on this one, definitely I'm going to see the object like a three-dimensional solid. So this is like a box. Now I can understand that this is three-dimensional solid. This three-dimensional solid is a box with length and width and height. Length extended along x-axis, width extended along y-axis. As you can see, this base is located in the xy plane, and the extension it is along z-axis. So this is a three-dimensional solid. Now I can understand that this is a three-dimensional solid, and as you can see, even the view box is seen like it is a cube, a three-dimensional thing. How about if you're interested in the front? You're gonna click on the front, you're gonna reset back again to the two-dimension. If you clicked on the corner, you're gonna move here to the isometric. Also, you can click on the edge. On the edge, you're just gonna give alignment to this object, and you just gonna focus, put the focus over this edge. But in terms of engineering, this is not engineering thing. The engineering thing would have two standards for creating three-dimensional sketches, either isometric or oblique view. The oblique, this is for the American system, and this is what we weren't gonna use this one. We focus on the ISO system, which is the isometric. So we need the isometric representation of the 3D object. So make sure to switch to 3D solid or 3D representation. Make sure that you click on one of the corners. I can look at it from the other side. I can look at it from this side, and so on. So it is like kind of you already handling this 3D solid and giving it like kind of rotation. Make sense? So this is how we can use this box to give different angles, to see this 3D solid from different angles, and we can see that's two-dimensional thing, or one projection. We can see one projection of the 3D solid, or even we can see the three-dimensional representation of the 3D solid. Definitely, I didn't explain to you how did I create this box, but definitely I'm gonna explain to you everything with more detail how we can create 3D objects. But now we're just focusing or discussing how we can change the view of this 3D solid, how we are going to look at it. Make sense? Also, one of the things, how about if you would like to handle this navigation bar, this navigator bar, this one like orbit. Orbit, for example, this is one of the icons. If this one is not shown, you can show this one from the status bar down here. Or simply, you can just type orbit in the command window. We said that anything that's, if you just remember the name of the command, just type the command name, you already recalling this command automatically. So if we press on this one, we can and just left click and keep continue left clicking on the object. On this object, you're gonna give it, as you move the mouse, you're already handling it. You're gonna give it like kind of rotation, and you can rotate this object the way that you want. And there is an option, by the way, in AutoCAD that we can record this movement. So this is one of the things, for example, as you can see, like just observe this view box. As we giving rotation, we can keep recording this kind of motion that would provide this object. So we're gonna end up with animated movie of this 3D solid if we are interested in fancy things of the representation of these 3D solids. Make sense? So these are different ways how we can change the orientation and change the view, how we're gonna look to this 3D solid. Another option is, or another thing that we can play with this 3D solid is the visual style. What does it mean, a visual style? Just to explain it to you where you're gonna find it, let us expand this one. So in the layers in the same 3D, here I'm working on 3D basics. Then I'm gonna show you how you can find the same panel but for the 3D modeling. For the 2D, for the 3D basics, you're gonna find in layers and view. You're gonna find here this one of the option. The second list here, the first list is for the layers. The second list is for the visual style. Visual style, there are some standard things. Visual style, by the way, and how we are representing 3D solids in different ways. Visual style is how you can represent the object, how in terms of visualization, how you're gonna see the object. And it is here we are not talking about the view. We are talking about how we're gonna see the object. Is gonna be like two-dimensional frame, and this is the default thing in AutoCAD, or is gonna be like conceptual, like this way, like I'm gonna see like it is really a solid, or are you gonna, as you change the visual style, for example, as in this case, this is a 3D solid, but the other edge down in the back here and this edge here, this edge should be hidden. It shouldn't be there. Why? Because from this angle, you aren't gonna see this object or these edges. So that's why if you choose this type of visual style, you already hiding any hidden edges that should be hidden from this view. Realistic, it will be like a real object, and you can even play with the color of this object. Like you can change the color, and the visually you can change its color to black, white, red, green. It's up to you, or you can play with the color. Even one of the things that we can map images over this solid object. So we're gonna give it like a real feature. Like for example, you can build a face of somebody, and you're gonna put the image of this guy over this face. So you're gonna like building a 3D solid of his face, of this guy. So this is also one of the feature, and it's gonna be much more advanced definitely in 3D Max. So again, as I said, since it is the same company, they already bringing some of the commands in the 3D Studio Max, and they are using them and implementing them in the AutoCAD. Also, we have other things like sketches. This is like fancy things, as I said, like you already drawing this box by hand, or it would be like this is sketchy, or it would be X-ray, like it is like transparent box, or it would be wireframe. So all of these different things are different ways of how you're gonna see the 3D solid. By default, AutoCAD represents the solid as two-dimensional frame as long as you started here by ACAD ISO. But if you started with ACAD 3D, it will be represented as in this form. If you started the template by ACAD ISO, it will be seen in this way. Okay, but if you started with ACAD ISO 3D, it will be represented this way. But if you started with ACAD ISO, it will be seen two-dimensional frame. Then you have to go to this visual style list and change the list the way that you want, the way that you're gonna see the object. Now I can see that this is a solid object. I can understand more that it is really a three-dimensional solid, and even you can handle it, you can give it rotation. So simply, this is how we can switch the visual style and the view. The view, you're gonna use the view box, and even you can choose this orbit. Or also for the visual style, you're gonna use the visual style list here. This is for the two-dimensional, for the 3D basics. This list, the visual style in the 3D modeling, you're gonna find it here. If you switch to the 3D modeling, you're gonna find the view. If you're gonna go to the view list, there are some advanced things in view. Probably we may need some things if we are interested in representing this object into like 3D solid and multiple views. Probably we may discuss this thing. But anyway, in the view panel, you're gonna find the list of the visual style that you can change from two-dimensional work frame into shaded object, like you're gonna see like a solid object. It's up to you. So this is simply how we can play with the visual style and the view of the 3D solid. Alright, so since we already knew how we can switch between the visual style, the view, the different, how we can see the object with multiple views between 2 dimensions, 3 dimension, now let us move to know how we can build a 3D solid. And I'm gonna start with the standard shapes like box, cylindrical shape, these simple objects or shapes, how we can build them. This is the objective of this video. Then in the next videos, we're gonna discuss more advanced tools of building 3D solids like extrusion, revolve, sweep, and loft. We're gonna discuss these things, even how we can do editing to a 3D solid that we already built. These things will be covered over the next videos. So, to create an object, the first, as long as you're already working in 3-dimensional basics, you're gonna use the create panel. If you're already working in 3-dimensional modeling, you're gonna use also a similar panel, but it is named modeling. So the same commands, and today we're gonna focus on these standard shapes: box, cylinder, cone, sphere, pyramid, wedge, torus, how we can build these 3D standard objects, how we can build them using AutoCAD. This is what we are going to discuss. Or if you're already working in 3-dimensional basics, you're gonna find the same list here of the commands that we are going to discuss. Starting with the box, as I mentioned, to create a 3D solid, we should start with a 2-dimensional sketch. So once we choose the box command, and again, remember that you have to read the instruction. This is your teacher, this is your guidance. Read the instruction in the command window. Follow these instructions. As you can see, how we're gonna see the cursor here, it is seen as 2 intersecting lines, indicate that AutoCAD asks us to pick a point, as we discussed before, right? And this is very clear from the command window, that the command itself, it is box, and AutoCAD asks us to specify first corner. He asks about a point, so we have to specify the first corner of a box. Any box to be created as a 3D solid, it should have a base, and it should be extended. So the base for a box, it should be rectangular base, and it will be extended with a specific height. This is simply how we can represent a box in 3-dimensional modeling. So your objective is just to draw a 2-dimensional sketch. Definitely, by definition, this 2-dimensional sketch, it should be a rectangular base. You're just gonna start by drawing the base. And remember that this base will be seen over the XY plane. So your objective is just to click one corner and click another corner. This is gonna be the rectangular shape of the base. In this way, another corner. So I got the base. Then what? So just let us repeat it again. So AutoCAD asks us to specify one corner, the first corner. Then how about the other corner? He asks the other corner for the other corner. So this is the other corner. Then he asks us to specify the height. As I said, to build a box, we should build a base of rectangular shape, then we're gonna extend it with a specific height. Then you can type the height value. We can give a height, for example, like 800 and press enter. So as you can see, the cursor had been converted to the default shape, like 2 intersecting lines, and there is one box in the middle. This indicates that there is no activated commands, and this is very clearly seen in the command window that there is nothing written there. So it means that we already created the object, but we don't see the object. How we can visualize or see it? We can look at it in 3 dimensions in this way, like it is very long column, right? And even you can go to this visual style here into layers and change the visual style to be like in this way. So you're gonna see like it is a standing column. Make sense? The base was represented over the XY plane with a rectangular base, then we extended with a specific height. So we got this box or this column. So it is a 3D solid. Convert 2-dimensional sketch, then with another step, you're gonna end up with a 3D solid. We can even create this solid in the 3-dimensional space. We started from 2 dimensions, then we converted into 3 dimensions. Can we work over 3-dimensional working sheet? Yes, we can build it automatically. Like if we choose box, and it's gonna be much more recommended if you would like to build an object, especially in the start. So you're gonna see how you're already extending the object. Like for example, AutoCAD asks us to specify the first corner. So this is the first corner. then it's gonna ask me to specify the other corner. Now I can see the base, how it builds. So this is the second corner. Then it asks me, remember that I'm just moving the mouse up. As you move up, you're already extending up. If you would like to extend it down, you can switch down. So if you're already working in the 3D space, you do have more options over working from two-dimensional in the two-dimensional wireframe, in the two-dimensional space. In the two-dimensional space, we weren't gonna able to provide this ability to extend up or extend down unless that we have to add the height, because now AutoCAD asks us to specify the height. If we provided the height with a positive value, so it's gonna go to in the positive X. If we give the height in a negative value, it's gonna move in the negative Z. So if we're already working in the two-dimensional and we're building this solid and we are interested to extend this object up or down, we can give positive or negative. But in the 3-dimension, your objective is just to move the mouse up. If you are interested in extending it up, or if you are interested to extend it down, you're gonna move the mouse without clicking anything down, then you're gonna give the height value, 200, and press enter. So it had been extended down with a height or thickness of 200. Make sense? So this is simply how we can build a box using 3D Solid. But this is not the only way of building a box. So for this way, for this box, we specified one corner and we specified the other corner, and then we extended with a specific height. But the question is, we have no clue where is the first corner, the location, the exact location of the first corner, nor the second corner, but we can specify this location as points. The same way as we did, like typically, like you already drawing a two-dimensional rectangular shape. Make sense? How about if you are interested in drawing or representing a 3D solid of a box by specifying its length and width and height? Like the previous method that we had to specify the corner, then the second corner, then the height. How about if you don't know where is the coordinates of the first corner and the coordinates nor the coordinates of the second corner, but you do have the height? How about if you would like to give the length, the width, and the height, but you have to specify a point where it should be, this box be located within the workspace. This point is going to be the center. So if you decided to specify or to provide the length, the width, and the height, your objective is, once you choose box, AutoCAD by default asks us to specify the first corner. Don't give the first corner, and instead switch to this option center by pressing C and enter or click on it. So you're gonna ask AutoCAD, you are telling AutoCAD, no, I don't want to specify the corner, instead I'm gonna give you the center. So you're just gonna specify the center point of the box. As you can see, it moves, is extended in all directions starting from the center point that you choose, right? But then it's gonna ask you to specify next corner. You can even specify next corner and start building an object. But as you can see, it is extended in both directions. If you specify a corner, you're already extending in both directions, then you're gonna give a height. So it means that if you specify the center, like you are assuming or telling AutoCAD to consider the center point that you specified at the beginning as the core of this box, and it will be extended in all directions. This is one of the options. Also one of the options, if you're interested in specifying back again, specifying the length, width, and height, choose center, then you're gonna locate the center point, then it's gonna ask you to specify corner. Don't give the corner, and instead give it the length. Go to the length option and click on it, then it's gonna ask you to specify the length, how much it is. Assume that we do have a length of 200. And then it's gonna ask you to specify the width of this box. The width, how much it is, for example, like 50. And how much is the height? Assume that it is like 200. So we're already getting a box. But as you can see, the box is kind of oriented. It is not parallel to the X or Y. It is like having an angle, right? This basically depends on this way. So I'm just gonna repeat it again. If we choose the center in this way, this is the center point, then it's gonna ask us to specify the length, and we're gonna move to the length, L, and enter. Then if as you can see, there is an angle. Do you see this angle of the dynamic cursor? This angle. Now the angle is 90 degrees, the angle it is 180 degree, or it doesn't matter. Like we can switch the angle, and as you can see, the line it is like kind of rotating about this center point, and we can give it a length. So for example, the current angle is 118, and if you type the length value, you're already extending this length at this angle. It means that you kind of giving rotation of the box with this angle 118. Make sense? So if you decided to work with the length and width and height, and you would like to keep it as it is much as by default it should be oriented with the XYZ plane, it is advised to work in 2 dimensions. Like you just gonna move here to the top view, make sure that you're already working in the XY plane, and switch back again to the visual style to the 2-dimensional sketch. So 2-dimensional wireframe. So now we're already working in 2 dimensions. Then I'm just gonna choose box. I'm gonna specify the center point as 0, 0, which is the 0 point. I'm sorry, the center point. I'm just gonna choose center. Then I'm gonna type 0, 0. This is gonna give me the center point of this box. Then you can give the length and the width. I can give the length, for example, like let's say I'm just gonna move to the length option, choose the length. Then it's gonna ask me to specify the length. Make sure that you can activate the F8 to make sure that it is 90 degree or the length. In which direction do you need the length? Is it horizontal direction or vertical direction? So you're gonna specify the length in the horizontal direction 200 in this way, and then it's gonna ask you about the width, how much it is. I'm just gonna specify like 80 in the Y direction. So this is the length and the width. Then it's gonna ask me about the height. I'm gonna give it like 300. So now I got the box. If you moved back to the 3-dimensional representation, you're gonna see it as isometric. Go to the isometric view, you're gonna see the box. Make sense? If you would like to give it an angle, we can give it an angle the same way as we explained. In the 2-dimension even, you have to deactivate. If we reset back again to the 2-dimensional wireframe, even you can work, by the way, you can keep the visual style in this way, and you can go to the 2-dimensional top view, and you can work the same way. You can work in 2 dimensions here. So you're just gonna choose the box from 0, 0, or let us choose the center of this box 0, 0. Then it's gonna ask us to specify. We're gonna ask him to specify the length. Now you can give an angle. If you deactivated, if you activated the F8, you're already giving it either horizontal or vertical, which the length value, or you can give it an angle. Then you can specify the angle by switching the tab as we did in the 2-dimensional sketching, like an angle 45 degree. Then you can switch back again to the length and give the length, for example, like let's say like 15, right? And then you can give the width like 6, and then you're gonna give the height like 10. So you're gonna end up with the box who's already oriented with 45 degree with respect to the x-axis as already shown here. And even you can switch to 3-dimensional representation, so you're gonna see it like in 3-dimensional thing. Make sense? So this is simply how we can draw one of the standard shapes, which is the boxes, how we can represent them. How about if we are interested in a cube? The cube, it should be all the edges are equivalent. It means that you have to specify only one thing, then you can directly end up with a cube. So for example, if I decided to draw a box and he asked me about the first corner, so this is the first corner, then he asked about the other corner. No, I won't gonna specify the other corner. Instead, I'm gonna move with the cube. I'm interested in a cube with all edges are equivalent or are the same. So I'm gonna choose the cube. Then it's gonna ask me how much should this specify the angle length. I'm sorry, this specify the length, how much it is of this cube. So let us type 10 as the edge length of the cube. And we can even give it orientation the way that we want. As you move, you're already giving an orientation. If you tab, you're already switching to the angles. You can give it an angle, let's say like 135 degrees. Then you're gonna tab back again to specify the length like 10 millimeter. So already drawn a box, a cube. This cube, it is all the edges are equal of 10 millimeter length, and it is oriented with respect to the x-axis, positive x with 135 degrees. Make sense? So this is for the first command, which is the box, how we can create a box. Slender It is very similar to the box. But something that I'd like to demonstrate regarding the box here, remember that we start from two-dimensional sketch, then we convert it into 3D model. The two-dimensional sketches for the boxes, for cubes, it should be rectangular base. Then it will be extended with a specific height, right? How about the cylinder? How about if we decided to draw a cylinder or to build a 3D cylindrical shape? The base definitely is gonna be circular. Then it's gonna be extended. So what is the difference between box and cylinder? The procedure is the same. The only difference is in the box we are drawing rectangular base, but in the cylinder we are drawing a circle. This is the only difference. But it's gonna be the same two main steps. Draw the base and extend it. The base, rectangular or circular, you're gonna end up with a box or cylinder. It depends. For the cylindrical shape, you're gonna find the cylinder at the next command, which is the cylinder. Simply, if we're already working in 3D in this way, so simply, if you choose the cylinder, the first thing AutoCAD gonna ask you is gonna give you an option to draw a circle. All of these options, we explain them in two-dimensional and we discuss them and we consider them when we created a circle. We discuss how we can draw a circle by a center and give it a radius or a diameter. We discuss drawing a circle between 3 points. We discuss drawing a circle between 2 points. We discuss drawing a circle by tangent and radius of 2 objects. We discuss all of these things. We didn't discuss the ellipse. We can draw the base as elliptical shape and we can extend it. But it won't gonna be a perfect cylinder shape. No, it's gonna be with an ellipse base and we can extend it if we are interested in such a case. So we have to use the elliptical shape or the elliptical option. But for the circular, you can use any one of the methods that we explained for two-dimensional sketching of circles. To draw a circle, then you're gonna extend it then you're gonna give a height. You're gonna automatically end up with a cylinder. So let us assume, for example, the center, because he asked me about the center point. I'm gonna specify the center point as 0, 0. This is the 0 point. Then I'm gonna give the radius like, let's say like 10 millimeter. And then he asked me about the height. You can again extend it up or down. It's up to you. You can extend it up with a specific height, 5 millimeters, so we end up with a cylinder extended on this direction, or you can extend it down the way that you want. It's up to you. So this is gonna be 2 millimeter as radius, and then the height it is 5 going down. You have to move with the mouse down first, then you're gonna type the value or click. You're gonna end up with this height or the cylinder already extended in the other direction, in the negative Z direction. Make sense? So this is simply how we can draw a cylinder, and we can use any method of drawing the circle. You can use 2-point, 3-point, tangent. You can specify the diameter, you can specify the radius, the same way that we explained before for drawing a circle. Make sense? Now let us move to our next command, which is the Polysolid command, which is this one. We're gonna go over these ones definitely, but let us discuss the Polysolid command. Polysolid, it is like building 3D, as already written here in this preview. It is 3D wall like Polysolid, like you're already building walls of an object, like you already build 3D walls, and as you draw a line, you're just gonna end up with a wall. So the thing that in terms of drawing and sketching, your objective is just to draw lines. Typically the same like drawing polyline, and we discussed this polyline command before in two-dimensional sketches. So your objective is just to draw polylines. Automatically AutoCAD gonna convert these polylines into walls, standing walls. This is the basic idea of the Polysolid command. But to use this command, you have to set up this wall first, because the only thing that you're gonna do is your objective is just to draw lines, keep drawing lines, and that's it. But you have to specify the width, the height of this wall first. Okay, so for example, if I decided, let us remove this thing and choose the Polysolid command. So the first step is gonna ask me to specify start point. So I'm just gonna click any point to be start point. Then it's gonna ask you to specify next point. So as you can see, there is a standing wall, and as you keep clicking, you're gonna end up with extended walls. Then you can even close the shape. If you are interested in closing the shape, like you're already building a room, like it is like 4 or 5 walls of or edges of a closed room, so you have to close the shape. To close the shape, you have to use the close command here, this option, or you're gonna type C and enter, you're gonna close the shape. This is typically the same procedure that we did when we draw a polyline. In polyline, we are doing the same. Your objective is just to draw a line, keep clicking, you're gonna end up with multiple lines. Then if you would like to close the loop, you're just gonna type C and enter, very simple. Even one of the options in the polyline command, even you can work in 2 dimension. If we decided to work in 2 dimension, like if I choose Polysolid, you're gonna click here, so this is one wall. You can even activate the F8 to have like extended horizontal wall. And then you're gonna go vertical, then you're gonna go left, up, right. How about if you don't have an arc, we can convert to arc. So you're gonna choose the arc command. If you type A and enter, you instead of drawing straight walls, you can draw curved walls. Okay, and if we activate it, for example, deactivated the F8, we're gonna end up with like multiple curved walls in this way. Then we can close the shape. If you just type C and enter, you're already closing the shape with an arc. So this is like a beautiful, like assume that this is like the walls of a swimming pool. So this is like a very beautiful shape of the swimming pool, for example. And you're gonna look at it in the 3 dimension, it will be seen like standing walls, as I said. Make sense? But the question is, how much is the thickness of this wall? We have no clue. How much is the height of this wall? We have no clue. He didn't give us an option to specify the width or the height of this during the procedure. What we did simply is typically the same thing like drawing polyline command in 2 dimension. But we have no clue how much is the width or the height of the wall. So before drawing the lines and using the Polysolid command and drawing the lines and drawing the walls, you have to set up the wall first. You have to specify how much is the width, how much is the height of the wall first. This is the width of the wall and this is its height, how much they are. To specify this should be before drawing any, even clicking the first start point. Like for example, if I choose Polysolid, the first thing asks me to specify start point. No, don't specify anything. But you have to define the width and the height of the wall first. So you're gonna go to these 2 options, height and width. If you type H and press enter, now AutoCAD asks you to specify the height. By default it was 80. No, I needed 100 height. And press enter. Now it's gonna ask you to specify the start point. Don't specify the start point. Why? We didn't specify the width of the wall yet. So we have to specify the width, W and enter. Then it's gonna ask you about the width of the wall. Assume that it is 4 millimeter and press enter. If this is the option and you are satisfied with this option and nothing more that you would like to add in terms of width and height of the wall, so your objective is just to click the first click and keep drawing the walls. And then you're gonna type C and enter to close the shape. So we already got the walls. The height of the wall is 100 as we specified, and the thickness of the wall is 4 millimeter as we specified. So before clicking anything, you have to define the width and the height of the wall first. Make sense? Also, one of the options here, if we just remove this one and go back again to the Polysolid, one of the options that you're gonna see without clicking anything still, justify, that you have to do or define the justification of the wall. Is it gonna be drawn on the left or the right or the center of the points that you're gonna specify? For example, if it's gonna be much more clear if we move to the 2 dimension in this way. And if let us choose the start point, he asked me about the start point 0, 0 and enter. And I'm just gonna type here F8. As you can see, look at it, just observe. As you can see, the start point, which is the 0 point, even if I clicked here, this point that I clicked here, it is exactly in the middle of this width. This is the wall width, right? And this point that we choose, even the center, the start point, which is 0 point, it is located in the middle, in the center of the wall. This is by default. But how about if we need, for some reason, we want this point to be on the left of the wall or on the right of the wall? How we can do it? Okay, on the left or the right of the wall. To do it, basically, before clicking anything, you have to choose the justification. You have to define the justification of the wall. So once you choose the Polysolid, you have to go to justification. If you just type J and enter, you're gonna end up with this list. By default, it is in the center. So the points, because what you're gonna do when we draw the wall, we're just gonna draw lines and we're gonna specify points. So these points that you are going to define, are these points located in the center of the wall or located on the left of the wall or the right of the wall? Where is its location? So for example, if we switch to the left, and now we type 0, 0, you're gonna see that the 0 pointer is already on the left of the wall. Then we do have another point, then we can keep going. So as you can see, the 0 point was on the left of the wall. If we change the justification, J and enter, to the right, and we try to specify the 0 point, the start point 0, 0. So as you can see, the pointer is located on the right of the wall. It means that the wall will be located above the point or on the right of the point. The point itself, it should be on the right of the wall all the time. Here it's gonna be on the right of the wall because I'm extending in this direction. If you're extending in the opposite direction, I'm extending to the left. So your face, it should be facing the left side, the left direction, the negative X direction. So this 0 point, it will be located on the right of the wall. If you're already moving to the right, you have to turn your face to be directed to the positive X direction. And in this case, this point, it should be on the right of the wall as well. So you're gonna see the wall is kind of jumped up. Make sense? So you have to specify this justification. The easiest way is just to make it center, and this is what we basically do in terms of by default. But if we are interested in specifying these points that located on the left or the right of the wall, we can switch by this justification. This is simply how we can use this command, which is the Polysolid. Also, we can use it for building, like these walls, standing walls. Make sense? Now let us move to another command, which is the cone. The cone, any conical shape, it should have a base of a circle, and it would be extended to the end with a decreasing diameter or radius of the circle to be 0 in the tip. So any conical shape, it should have like a tip, but it would be trimmed. We can draw like a trimmed cone, like as shown here in this representation, right? So in general, how we can draw any tapered surface or tapered object or solid or even conical solid, how we can build this thing. So simply it's gonna be very similar thing that we used to do for the Slender. Draw a circle for the base, then extend it with a specific height, you're gonna end up with automatically with the cone. So the cone, if you clicked on this command, as you read down there, specify the center point of the base, and you can either use the 3 points, 2 points, tangent, radius, or the elliptical option, which is typically the same thing like the Slender or drawing a conventional circle. Like if we decided to draw a circle from a center point 0, 0, this is the center point, then it's gonna ask us to specify the radius of this base, or even you can specify the diameter if you do have the diameter value. So let us specify this radius or like 100 and press enter. So we end up with this small circle of the base. Then we can automatically ask us to specify the height. If we give the height, let's say like 200, we're gonna end up with a standing cone with the height 200 and the diameter of the radius or the radius of the circular period is 100. How we gonna see in the 3 dimension, if you're gonna look at it, will be standing in this way, then we can switch the visual style to be seen like an object, solid object. So this is the conical shape in the 3-dimensional representation. So it is very simple procedure. Draw the circle and give a height. Make sense? But how about if I'm interested in drawing this cone as trimmed cone, like I would like to trim the top. It is, as you can see, that the circular base, it is extended with decreasing radius till 0 on the top. How about if you would like to specify specific radius, whatever it is smaller, like this case, or bigger than the base radius, we can do it. So if I repeated this conical shape again, but in the 3 dimension to be clear, and starting from 0, 0, this is the center point. He asked me about the radius of the base radius. So I'm just gonna give it by 100. And then he asked me about the height. Don't specify the height. Instead, ask him to define top radius. I need another top radius. So two radius that you're gonna define. One radius for the base, another radius for the top. So click on it or just type T and enter. Then he's gonna ask you to specify the height, the radius of the top. So how much is the radius of the top? It would be bigger or smaller. The base radius we specified as 100. You can specify the radius on the top to be, let's say, like 50. So it's gonna be half of it. So it's gonna be smaller. Then it's gonna ask you about the height. You can extend up or you can extend down. It's up to you. So your objective is just to move the mouse either up or down to specify the direction. Then you're gonna type the value. So extended up, I'm gonna type the value as 200 and press enter. So we're gonna end up with a conical shape with trim tip. Like the base it is with 100, the top surface it is with 50 radius and the height it is 200 of this conical shape. We can even have this circle with a bigger radius by, instead of providing the 50, we can give it a bigger radius so it will be seen in this form. So this is simply how we can draw a cone using the AutoCAD. It is very similar to the pyramid. Pyramid or any other base, it is very similar concept as the cone. We can have even the top with trim top, or it would be like a complete pyramid shape. The pyramid by default, it should have a base, and this base it should be like square or rectangular base, but it is extended into 0 on the top. This is the complete pyramid shape. But there is an option in AutoCAD to draw the base as a polygon, and instead of just being 4 sides or rectangular or square, it would be a hexagonal or any other polygon shape. This is an option and we're gonna see this thing. So if we choose here the pyramid, this is the other command, it's gonna be very similar like you drawing a circle. So it's gonna ask you to specify the center point. So I'm just gonna type 0, 0 for example for the center point. Then it's gonna ask me about the radius of the base. As you can see, if you can observe, there is like kind of a circle. There is like kind of a dashed circle that tangent to these edges, and all of these edges are inscribed. The circle is inscribed, and this is or the circle, the edges are circumscribed. The circle, I'm sorry, the edges of the base already circumscribing the circle. It means that they already tangent to the circle outside the circle, from the outside. But if we are interested to make it inscribed, which is very similar thing that we explained before for polygon. It is the same approach for drawing polygon, but this polygon by default is 4 sides. So it is, you can choose even, for example, inscribed. So as you can see, there should be like a circle outside, and these edges already intersecting to this circle, and they already inscribed inside the circle. So you can switch between the options, either inscribed or circumscribed. It's up to you. Like this way or this way. Make sense? So for example, like this case, it is inscribed, it is circumscribed. In this case, it's gonna be inscribed. Then your objective is just to specify the base radius, how much it is, like you're drawing a circle. So I'm gonna specify the base radius, but remember that you have to keep the base oriented. As you can see, there is an angle that it changes here. You can tap on it to this angle and specify the angle, let's say like 180 degrees. So you are giving rotation to the base with 180 degree. Then you're gonna specify and click. I clicked on it, so I'm just gonna repeat it from the 0, 0. Then before you specify the radius value, I'm just gonna tape to the angle and specify the angle 180, then I'm gonna tape back again to specify the radius like 200. So I'm already drawing a box with the base oriented 180 degree with respect to the x-axis, and then he asked me to specify the height. So as you can extend it up or extend it down, it's up to you. I can extend it up with a specific height, let's say like 300, so we're gonna end up with a pyramid shape. Make sense? So for example, how about if I'm interested in specifying another number of this base sides instead of just being 4? By default, they are the number of the sides of the base of the pyramid that is just 4. How about if we needed 5 or 6, any polygon number of sides? So how we can do it? He asked me to specify the center. Don't specify the center, and instead go to the sides, specify sides. So if you just type S or just click on the sides word here and press enter, by default it is 4 as I mentioned, but we can change it to 6 sides, for example. So it's gonna be like hexagonal base and it's gonna be extended, and press enter. Then you're gonna follow the same procedure of drawing the base like a circle. So you're gonna specify 0, 0. Then it's gonna ask you to specify the radius of this circle, and you can use it either striped or circumscribed or inscribed. Then you're gonna specify the radius like 200 and press enter. Then you can extend it up or down. So you're gonna end up with like extension of 200 and press enter. This is gonna give us the height. Make sense? So this is how we can create also a polygon or a pyramid shape with a base of more than 4 sides. This is what we can do. Also, how about if we are interested in making it trimmed? As you can see, these points or all of this base already the points of the corners or the vertices of the base already are these points are meet together in one point on the top. How about if we need it trimmed as shown here? So he's gonna ask us to specify a point, so we're gonna specify the 0, 0 point, and we're still using the same 6 sides of the base, and we specify the first radius. Then he's gonna ask me about the height. Don't specify the height, do the same thing as we did for the slender, and instead go to the top radius. I want to specify a specific radius to the top. So if you clicked on this one or you just type T, you can directly move to specify the radius of the top, and you can give a value, let's say like for example 500, and press enter. Then it's gonna ask me about the height, how much of the height. So this is the base. The base is the fixed thing, and what I'm moving here is the top or the other side. It would be extended down or extended up. As you can see, the second radius that is specified, it was bigger than the base radius that I'm building on. So your objective is just to specify height, like, let's say like 300, and press enter. So we're gonna end up with a pyramid shape with trimmed thing on the top. It is like tapered thing, extended with an angle as already shown here. This is one of the things that we can do using AutoCAD. This is for the pyramid command. What next is the sphere. Sphere is very simple command that simply you're just gonna specify a point and specify radius, so it's gonna be much more simple than the other commands. To draw a sphere, 2 steps: specify a center, then specify the radius, like you're already drawing a circle. Very simple thing. So the center point is gonna be 0, 0. Then your objective is just to give a radius or a diameter of this sphere, let's say like 200 radius. So we're gonna end up with a sphere, a spherical shape in this way. Make sense? So the sphere command is very simple command that we can create. So the next command is the wedge, which is this one. This is gonna give like a slide, kind of like inclined surface, building a 3D solid of inclined surface known as wedge that already gives like a support of different tools. Like if you're already having a standing wall in this side, and you would like to give a support to this wall over the ground, so you're gonna use this support or this wedge to do so. But anyway, how we can create it is gonna be created very similar thing, the same procedure like building a box. It is very similar to the box, so you could consider this wedge is like half a box, kind of. So you're just gonna follow the same procedure of building a box. So once we click on this icon of the wedge, the AutoCAD gonna ask us to specify the first corner of the base. The base again is gonna be like rectangular base like this one. So I'm just gonna specify the first corner. Then it's gonna ask me to specify the second corner. So let us assume that this is the second corner. Then it's gonna ask me about the height. So as you give on height, you're gonna automatically end up with the wedge in this way. So it is like a slide, kind of like sliding or inclined wall. This is how we can build the wedge. Last thing that you should understand about the wedge, that the inclination of the surface of the wedge, it is all the time directed in one direction by default in AutoCAD, which is the x-axis. And if we would like to switch it, we have to play with the UCIS, with the UCS, which is the user coordinate system. It means that we have to give rotation to the coordinate system so we can give an alignment or rotation to the slides or the taper of the wedge itself. This is one of the things that you should understand about the wedge. For example, like if you specify, he asked me to specify this, the first corner. So this is the first corner. This is the second corner, for example. So as I'm building up, as you can see the slides, there is a slides in this direction. I cannot give it any other direction unless you switch the x-axis direction or give rotation to the coordinate system. By default, all the time it will be inclined in this direction. Even if you did whatever you do, like for example, if I clicked here, then I move the other side, it will be also oriented in the same direction. If you would like to have this slide differently, like instead of sliding in this direction, sliding in the opposite direction, for example, like you're already giving rotation to it, we can do it, but we have to switch. We'd have two options, either to edit the solid object, and this is one of the things that we can do, or give rotation to the object through the edit command here, or simply we can do like orientation or rotation or changes in the coordinate system to make the x-axis oriented in a different direction or in the direction that we would like to have this taper surface in. So this is one of the things that you should understand about the wedge. And the last command here that we are going to discuss is the torus. This is the donut shape, like you're gonna build like a donut shape like this one here as shown here. And it is very simple command that your objective is just like you draw a circle and you're gonna specify the radius of another radius. Like you're gonna draw a circle, so you're gonna locate a center point, then specify radius, then another radius. So the first step is just to specify the center, or you can use any one of these options of drawing a circle. So let us specify the center point as 0, 0, and then it's gonna ask us about the radius or specifying the diameter. It's up to you. Assume that the radius is 100. Then it's gonna ask us to specify the radius of the tube itself. The tube, it should have a radius. The tube itself, it should have a specific radius. So let us define the radius like 20 and press enter. So we're gonna end up with a donut shape or a torus shape with the radius of this tube itself is 20, or as we specify, I forgot the number, and the diameter of, and this torus or this tube is already rotated over a circle with a radius of 100 as we specified before. So it is like you draw a circle, then specify another radius. I'm gonna repeat it again. Just draw, this is the center point, draw a circle with a radius, then you're gonna define another radius for the tube itself. Make sense? These are for the standard shapes, how we can create very quick these 3D solids of these standard shapes that already located into this list. This is what we discussed through this video. But in addition to these standard things, if we are interested in making more complicated shape, definitely there are some other commands that we are going to discuss over the next videos. Make sense? So that's it for this video, and see you in the next video to continue working on the 3D models. Thank you.